Hello children, welcome to e-classes in physics for class 12. Children, today we'll discuss Coulomb's law. In the last class we discussed the properties of charge, charging of a body and unit of charge. Okay, let us start our discussion. If you consider two charges, these are two charges, do you think they will interact with each other? Yes, they interact. And what's the interaction that you know that like charges repel each other and unlike charges attract each other? And let us consider two charges. This is both are positive charge. Then, and how will they interact? One, suppose this is charge 1 and this is charge 2. So charge 2 or charge 1 will repel charge 2. Repel means it will push outward like this. And similarly charge 2 again charge 2 will push charge 1 outward like this. So this is what repulsion. If one of them is positive and another is negative, they will attract each other. Attractor means they will pull each other like this. And this charge will be pulled like this. They will be pulled like this. This is what attraction. Now, how much attraction? What is the magnitude of attraction? What is the magnitude of this attractive force? All these things we'll discuss today, and this is given by Coulomb's law. Coulomb's law gives a quantitative measure of electrostatic force between two point charges. And to point charge, first of all I must clear this. What is point charge? A distribution of charge will consider point charge if the distance between two charges is large enough. The dimension of the charge distribution and that of the distance between the two charge r. If r is much more than the dimension of the charge distribution, then we'll consider this as a point charge. So let us discuss Coulomb's law. Here Coulomb's law, what does this law says, you see, is that the force between two point charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them. That is, if two charges q1 and q2 are placed r distance apart, okay, and then force F is proportional to q1 and q2, the product of magnitude of charge q1 and q2, and inversely proportional to 1 by r square, that is inversely proportional to r square, that is proportional to 1 by r square. So combining these two, what we are getting, F is proportional to q1 q2 by r square. This is the magnitude of charge, magnitude of force, and this is the magnitude of the product of q1 and q2. That is, here when we are talking about the magnitude, no need to consider the sign. Negative sign, no problem. Negative sign, positive sign, no problem. Magnitude will be that much. Now, F equal to, therefore you can write K into Q1, Q2 by R square. What is K? K is the proportionality constant. And K is given by 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught for vacuum. If we keep, vacuum means what? If we keep two charges in vacuum, that is in between the charge, there is no medium present, then that is the two charges are placed in vacuum, then this is equal to 1 by 4 pi epsilon naught. Naught represents for no medium. What is epsilon naught? Epsilon naught is called permittivity of free space. So Coulomb's force that is the magnitude of Coulomb force will depend on the medium. If we place place the charges in a medium, then the force will be different. Unlike the force in vacuum. The value of epsilon naught is considered to be 8.85 into 10 to the power minus 12 Coulomb square Newton per meter square, and together 1 by 4 pi epsilon naught we will put together. This is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, now this is what about Coulomb's law. Now Coulomb's law therefore gives us the magnitude of force. What is the magnitude of force on a charged particle when it is near another charge? Now this Coulomb force, why should we calculate Coulomb force? Why we keep interest in this force? To know this, let us discuss few things. Dear students, let me come to the atomic model. According to atomic model, and inside the nucleus all the positive charges are residing, and electrons are outside the nucleus, they are in their orbit. You know, orbiting, that is going around a circular path, it needs centripetal force. This centripetal force, who is to provide this centripetal force? In our solar system, you know, the sun provides centripetal force through the gravitational force to the earth. Similarly, in case of an atom, a nucleus positively charged and electrons are negatively charged, mass is very less, the gravitational force will be very less to make it move in such a circular path. So it is what electrostatic force which provides the centripetal force to the electron to revolve around the nucleus. Okay, so and I hope you remember in atomic structure chapter, you must have gone through this discussion that Bohr model of atom. Let me say one equation, and we formulate 1 by 4 pi epsilon naught q1 q2 by r square equal to mv square by r. Okay, this equation is very important in Bohr model of atom. This is one of the key equation, and that centripetal force is provided by the electrostatic force of attraction. And another equation he used, which is known as Bohr's postulate, that angular momentum, that is mvr is equal to nh by 2 pi. These are the two key equations for v and r as two variables. So we need two equations to solve, which was which was a suspense in case of Rutherford model. And from these two equations we can derive the value for radius of nth orbit, velocity of electron in nth orbit, energy of electron in nth orbit, and as well as then energy levels, all these things. This we cannot do without the help of this equation, that is the consideration of electrostatic force. So children, you must understand that the force, electrostatic force, the concept of electrostatic force is very important for us. One more thing, I must remind you, the size of an element in a periodic table decreases from left to right in a given period. I hope you remember. Okay, needless to say, you can use the concept of electrostatic force, that is Coulomb's law, to explain this phenomenon. Another thing, a common salt, that is sodium chloride, it is very much crystal in air, but whenever it is given in water, or we we drop a crystal of salt in water, it dissolves, it dissociates. What's the reason? The reason is again electrostatic force. The medium comes in between. There is change in medium, and there will be some difference in force of electrostatic attraction. That is sodium chloride. The force between sodium ion and chlorine ion decreases due to the change in medium, and this gives rise to the dissociation. Again, let me say about the reactivity of sodium. Let us compare reactivity of sodium and potassium. I hope you remember potassium is more reactive than sodium. What the reason? I hope you can explain this. I must keep my mouth shut. You and I am giving you a chance to explain this. And now let us consider a very simple problem. If you are happy to, if you want to enjoy this problem to be solved, okay, let us consider a very simple problem. Let us consider the force between we'll calculate the force between Na plus and Cl minus ions in NaCl. This is Na plus and Cl minus. Can you take this length as a bond length? That's the bond length. Take Q1 equal to how much? Q1 equal to 1 electronic charge. Q2 is equal to also 1 electronic charge, and the distance between them is one bond length. This bond length is about 2.36 angstrom. Okay. Now I hope you are able to calculate this. That is a force between these two will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and put this value 1 by 4 pi epsilon naught Q1 equal to 1 electron, that is 1.6 into 10 to the power minus 19, and that is equal to 1.6 into 10 to the power minus 19 divided by R square, that is 2.36 into 10 to the power minus 10 whole square. Okay, now you can calculate the force. Similarly, if we consider potassium chloride, again potassium chloride, what about the charges? Charges will be the same, but the bond length is equal to, is here, bond length is let me see, I don't remember this, that is 2.67 angstrom. So hope you can calculate this force also. So which one will be readily dissociated, that is which one will dissociate easily without much dissociation energy? Of course, you see here the R is equal to 2.67 angstrom, where here R is equal to 2.36 angstrom. So more the value of R, less will be the force and less will be the energy required to dissolve it. Now let me give you one problem. Problem 1, this will solve. Let calculate the force between, this is electric force or Coulomb force between two alpha particles separated by a distance of 1 millimeter. Dear students, you must take care of the units. Now, one more importance of this law, let me discuss. See, these are the points for exam point of view. That is, F is proportional to what? Q1 and Q2 by R square. Now, if we make some changes in Q1 and Q2, keeping R constant, then simply we can consider this equal to proportional to Q1 and Q2. Suppose only one charge is varied, then Q2 will be again constant. So if Q1 is made 3 times, Q2 3Q1 and Q2 remains Q2, then F will become how much? 3 into Q1, that is 3 times. F dash will be 3F. Okay. In this concept, let me give one question. That problem 2. The electric force between two charges is measured as F Newton. If one of the charge is halved and the other is made 3 times, what will be the new force between them? I hope you can solve this problem. Okay. Now let me discuss the change in that is variation with distance proportional to 1 by r square. Very simple. If we make r tends to twice r, then f will become how much? F dash will become f by 4. If we make r, it becomes half, that is r by 2. Obviously r by 2 whole square, that is f dash will become 4 times like this. So these are the simple problems you can solve, and these are also important and interesting for exam point of view. Okay students, therefore we discussed Coulomb's law, and you could understand how to calculate Coulomb force, that is the force between two point charges separated by some distance, and at the same time you can find the variation of force if Q and R are changed, and at different situations how to use Coulomb's law that you can do. My request is, my suggestion that you will solve a few questions from your NCERT book. First few questions you can solve very easily. Thank you very much.